to mathematical proofs, we'll be talking about functions. So you've dealt with functions before. The simplest way to understand them is an input-output machine. But more importantly, how do we formalize this, right? What properties do functions have and why are they important? Well, the last question should be answerable. Calculus, for example, is a study of functions that go from the real to the reals. So, of course, understanding what functions are is going to be super useful. And in regards to the properties, we might think of continuity, differentiable, but like, is there anything even more general than just stuff that's outside of calculus? In regards to formalization, that's why you're here. We'll use a diagram. We'll have two sets, A and B, and we'll draw them as an ellipse containing elements. So in this case, the left ellipse is going to be the set A, and it contains the elements 1, 2, 3, and 4. And the right ellipse is B, and it contains the elements A, B, C, D, E. Remember, they can just be any elements. In this case, we're just making sure that one's numbers and one's letters to differentiate them. So what is a function? It's a map that goes from one set to another set, and this is how we write it. So it maps elements in A to elements in B. So for example, here we map 1 to the element C. So the function will take in 1 and it'll output C. But a function isn't just any maps. There are actually two rules that a function must follow. A single input can't have multiple outputs. For example, if one goes to B and C, this is not a function anymore. Okay, secondly, every element in the input set must be mapped. So in this case, this is also not a function since 4 isn't mapped to anything. And finally, when everything is said and done, we'll get a function. So usually when we think of functions, we think of formulas, right? But it doesn't have to be formulas. It can be just any map from a set A to a set B that follows two rules. Everything gets mapped once. And now we're going to just talk about some notation. Here we say that f of 1 is equal to C, since f sends 1 to C. Likewise, f of 2 goes to B, f of 3 goes to E, and f of 4 goes to C. Now let's just run through some basic definitions that you're going to hear a lot. First is the domain. So the input set is the domain. So the domain of f is A, since that's the set of all of our inputs. The output set is called the codomain, or the set of all possible outputs. So the codomain of f is B. What's interesting here is that even though A is in B, it doesn't actually get mapped to. So you can think of the codomain as the set of all possible outputs. What about the set of elements that get mapped? So what do we call that? That's called a range. So the range of f is the set B, C, and E, because B, C, and E get mapped to. This is the set I like to call the set of achievable outputs. So these are the elements that definitely get mapped to. And that's technically all we'll need for this video. This is just introduction to functions, but it'll introduce a few definitions that we'll study in future videos, but they won't be asked about in the worksheets. So let's say we want a function from B to A, or in the reverse direction that takes everything back to where it was. We call this the inverse function. What would happen if we try to do this? In this case, if we try to see what happens, we say that C, if we were to try to reverse it, C would go to 1 and go to 4. That's not a function. That breaks our first rule. What word can we come up with that says that each input is mapped to one output only? This is called injectivity. So if we make sure that 4 goes to D, F is now inject, because when we try to reverse it, everything only goes back one way. C can go to 1, or B can go to 2, D can go to 4, E can go to 3. And some people like to use the word 1 to 1 because an element in A is matched up 1 to 1 with an element in B. But even now, if we try to invert this function or reverse the direction of the arrows, we still violate 2. Everything in B doesn't get mapped to, so when we invert it, we have issues since A doesn't map to anything when we invert this. So in order to create a map that goes from B to A, we need to make sure that every element gets mapped. So let's make a word that tells us the range is the codomain. So this guarantees that everything in the codomain or everything in B gets mapped to, so it is the range. This word is called surjectivity. So what we're going to do is we're going to introduce a point 5 and map 5 to A. Now F is surjective. And this property is called onto, since every element in A gets sent onto an element in B without missing any elements. Since F is surjective and injective, we can invert our functions. So we say that F is bijective. Bijective literally means it's both injective and surjective. And we can now reverse our arrows. And when we do, we get an inverse function that goes from B to A. And this is the notation that we use. And inverse functions are very useful, right? We're uniquely mapping all of A to all of B. In algebra land, we can compose functions or combine functions. So what is combining a function? You apply one function, then you apply another function. So what happens if we apply F, then F inverse? Well, let's take a look at an example. If we apply F of 1, well, F of 1 will send 1 to C. Then what will the inverse of that give us? It'll send C back to 1. So F of 1, or F inverse of F of 1, is just itself. And indeed, it works in the other direction as well. If we put F on the outside and the inverse on the inside, well, let's see what happens. We do the inside first. So F inverse of A, well, what's it going to do? It's going to send A to 5. Then F of 5 is going to send it back to A. Inverse functions work really nicely because the functions cancel out. F of F inverse or F inverse of F, when we combine those functions or apply one after the other, we just get nothing. So it goes back to what it originally was. Okay, nice. Let's just quickly recap everything that we talked about. A function is a map from set A to set B that follows two rules. One, an element in A gets mapped to only one value in B. And two, every element in A gets mapped to elements in B. We denote this as f goes from A to B. Or else, another way we can think about this is everything gets mapped once. And here's just a wall of definitions. If we have f from A to B as our function, the input set is called our domain, in this case A. The codomain is the output set, the set of all possible outputs is called B. The range is the reachable set, or the set of all achievable outputs. So elements in this set get mapped to under f. And we notice that the range of f is always a subset of B. Injective means that each input is mapped to a unique output. So every element in the range is mapped to uniquely. Surjective states that the range of f is actually equal to B, or the domain and the range are the same, so all possible outputs are achievable. And bijective means that it's injective and surjective. So a bijective function is invertible, and then we can actually have an inverse function. That's going to be it for now. I will see you in the next one.